Hello and welcome to part 1 of the Design Studio's two-part series on the Ultimaker 3D printer instructional videos. We're going to focus our attention to the left side of the table here, and we'll be focusing primarily on the Ultimaker 2 and its distant cousin, the 2 Extended, with the primary difference being the volume of their build capacities, as I've shown here. To get the printing process started, we'll first begin on our computers, and we'll go to the website called the Thingiverse, and utilize this file here seen on my screen that's called the Fancy Chicken. If you've not been to the Thingiverse before, I recommend it as a good starting point to understanding 3D printers. It's an open source database that gives you access to many STL files of varying geometries. This is a useful resource, as is shown today, to utilize test prints on these 3D printers while learning. In order to download the STL file, we'll press the blue button in the top right of the screen, and then we'll close out of the pop-up that generates. Now before we can open that file indicated on the bottom left of the screen, we'll have to download the software platform to interface with the Ultimaker. This is called Cura software and is developed by the Ultimaker company themselves. To download it, you'll press the blue button here, and if you have compatibility issues, go ahead and click the View All Versions button that is highlighted in order to access versions compatible with your operating system. Once Cura is downloaded and installed on your computer, it may open up with the left ribbon showing the Quick Print view as is here. To switch that, go to the Expert drop-down tab and switch to Full Settings. After clicking Yes, you'll have access to all of the settings that we'd like. Now let's bring in our part. We'll click Load Model File. We'll navigate to our file of interest, and you'll see it'll generate while loading the total print time estimation as well as the amount of material and the mass of material. Now we're able to drag our part around the virtual print tray by clicking and holding with the left mouse, and when the part turns gray it's off stage, yellow is on stage. You can see all the while the print time and estimation of material updates. For the sake of time, part 1 of this video series only will include me describing each of these parameters in the left ribbon verbally. Part 2 of the series involves me going more in depth and printing the same part over and over again on the Ultimaker machine, while varying just one of these variables each time. I highly recommend you check out that video at some point so you can gain a better understanding as to what each of these variables does to the end result of your part. So let's get started. Layer height is going to be the actual height of each pass of material the nozzle deposits. Typically, 1/10 of a millimeter is fine. For much higher quality, you're able to go 60 thousandths of a millimeter. Now moving on to the next setting is titled Shell Thickness. This is the outside thickness of your part in the horizontal plane. Now more or less this is going to determine how strong the exterior portion of your part will be, and when set with the layer height, decides how many passes are needed for each external portion of your piece. Now moving on to the next setting, which is Enable Retraction, which is toggled on or off. I always have this toggled on. Now this basically means that every time the print nozzle passes over a region that's not supposed to have material, the filament will actually be retracted into the nozzle to diminish the likelihood of depositing any unwanted materials in areas where it should not be. Now next up is bottom top thickness. You can think of this as shell thickness in the vertical axis for your part, and it's typically recommended that you keep this as the same value as your shell thickness for symmetry. Although due to the fact that FDM printers deposit the filament in layers, every part will be subject to anisotropic material properties that I demonstrate in another video. Now the next setting to talk about is fill density. This is listed as a percentage. I typically utilize 20% for most of my parts, and that is plenty strong. If you were to ever use 100% here, that would imply a solid fill to a part, and you should almost never need to utilize that as 100% fill density. One of the only scenarios where you may need to utilize 100% is if you have a very thin and brittle piece of a part. Overall, 20% will be fine. Now, to move on next, we'll talk about print speed. Now, this is going to be the speed at which the nozzle moves. I typically utilize 60 millimeters per second for our Ultimaker machine. And although the nozzle can travel well over 100 millimeters per second, it's important to remember that the higher that number is, the less accurate your print will be. The next parameter to discuss is support type. There are 3 options for this: none, touching build plate, or everywhere. As the name implies, none means that no support material will be utilized. Although this is warranted for some parts, most often it will result in a distorted part with skewed proportions due to the fact that the warm, malleable material will fall with gravity and will not be supported by the supporting structures. To To talk about the other two options, the difference between everywhere and touching the build plate is that when selected, the option of touching the build plate will only use support material that travels from the part to the build plate itself, whereas the other setting, everywhere, will involve putting support material from one area of the part to another area of the part. This is important to consider when debating how fragile portions of your part will be, as well as when considering the surface finish that will result after removing breakaway support material. The next parameter is platform adhesion type, and there are three options: none, brim, or raft. These are used to avoid the part from peeling off of the surface of the print tray. The primary difference between brim and raft is the thickness of the interface. Brim involves just one layer thickness and is very malleable and easy to remove from your material, but raft is a very thick lattice structure underneath your piece that is much more rigid and can be more challenging to remove from the base of your part. Now, after selecting raft for this part, we are going to discuss nozzle size. This is listed in millimeters and is dictated by the hardware of your machine, and for us we're going to use 4/10 of a millimeter. We'll turn our attention back to the build tray region of Cura, and we can look at the option of rotate in the bottom left. This brings up gyroscopic handles to allow us to rotate the part along all three axes. And there's a number of factors to consider when determining the best orientation of your part relative to the printer tray. I cover this component of 3D printing in detail in a former video teaching students how to best understand support material across various printing platforms. I highly recommend at some point that you check that video out to supplement your learning. Now, there's also the option to mirror. You can see here we're able to mirror along all three axes, and we can also scale the part. Now, the top left corner tells us the print time is about 3 hours. For the purpose of this demo, I'd like it to be closer to an hour, so we can grab this top handle and uniformly scale the object down. This is about 35 minutes, as you can see, so we'll make it a little larger, and that's just about where we want it to be at 53 minutes. Now that we've covered all the parameters and our part has been scaled appropriately, let's grab the USB adapter for the SD card, bring it back over to our computer, insert it into the USB slot, close the pop-up, and then go ahead and click the button titled Save Toolpath to SD. After clicking, you'll see an indication at the bottom of the screen informing you that it has been saved appropriately. Go ahead and remove the USB adapter, and then take out the SD card and insert it directly into the Ultimaker machine. To interface with this machine, we'll rotate this wheel. To press it, to click a button, and we'll click Maintenance and Build Plate, and then Continue. Now what we'll do is prepare the build tray for a successful print. Now I'm going to split the screen here so you can see my finger motion on the wheel as it corresponds to the motion of the build tray itself. As we rotate clockwise, we raise the tray, and counterclockwise, we'll do the opposite. The goal now is to bring it about 1 millimeter away from the nozzle head. Then we'll go ahead and depress the button to have the nozzle come to the front left area of the build tray. Now the goal is the same, to bring the tray about 1 millimeter away from the nozzle tip, except we won't be using the dial as we did before. We'll be using these set screws. It's important to note that in order to lower the tray, we'll tighten the screw, i.e. twist it clockwise, and to raise the tray, we will loosen the screw, twisting it counterclockwise. Now the front right of the tray also looks good, so we'll depress the button again and get ready for the next step of initializing the print. Now we'll take a piece of paper, we'll slide it underneath the printer nozzle in between that and the tray, and we'll rotate the wheel again until we feel a bit of resistance between the printer nozzle and the piece of paper. You don't want it to be too loose because then your part will peel off of the tray, and you don't want it to be too tight because then you risk damaging the printer nozzle as it drags across the surface platform. Now we're going to repeat the process in the front left, and again we're not going to use the wheel, we're going to use the set screw to get that similar form of moderate resistance between the nozzle and the paper. And once we have that, we're going to go back to the wheel, to press the button to press continue, and go ahead and do the same for the front right of the printer tray. It's important to be meticulous about this process, as most prints fail during the initial stages of printing due to the fact that the printed parts peel off the printer tray. A way to minimize this is ensuring that the printer tray is appropriately in line with the plane of the nozzle's guide rails. Next up, we'll take our putty knife and we will scrape away any remaining adhesive or print material on the glass tray, and take the glue stick and apply a layer over the region of the build tray that will interface with our part. Next, we'll go ahead and navigate to highlight the word print, to press the button, and navigate to the file that you have loaded on the SD card. After depressing the button, you'll see that the nozzle is heating up, and this is typically one of the most rate limiting steps of the process. Here it's played back at 4000%. And once it's ready to begin, you'll see the printer tray will rise and the filament will begin to be ejected from the hot printer nozzle. I find it helpful to use the putty knife to remove this initial filament in order to prevent the likelihood of a future clog, just to get any cold and hardened material out of the way. In the bottom right of the screen, I've included the image that is displayed on the machine, estimating the remaining print time left for each part. And as the print begins, the first component that is being laid out here is the raft, which, if you recall, is the interface that we selected between our part and the printer tray. As I mentioned before, most prints fail during the initial stages, so I recommend watching your part for at least the deposition of the first few layers if you can, to ensure no problems arise. Taking a view from above the machine, we're able to see that the raft is constructed via a lattice pattern with material deposited at a 45-degree angle relative to adjacent layers. We'll speed the video up to 5000% to watch the chicken come to life, and keep in mind that all of this bottom platform is the raft, and it's not until now that the actual bottom component of the chicken part itself is being constructed. At this point, you can tell the legs of the chicken are not very clearly delineated, and that's because they're covered in support material due to the fact that we selected support material everywhere. So from the base of the chicken to the underbelly and over the front midline of the chicken, there's support material. Looking from the top of the chicken, we can appreciate what 20% infill density appears to be. It's made up of a crosshatch of 90-degree lattice struts to one another. And we'll speed it back up to 5000% to watch the remaining chicken come to life. And during the last few seconds, you'll see the countdown, and you'll also see a screen indicating that the printer head is cooling down. Now, during this time, unlike other printers, it's recommended that you wait for the cooling process to finish prior to removing the part. Because there's a glass plate on the Ultimaker versus the plastic bottoms of other printers, it's okay to do this, and it will avoid the part warping when you initially try to separate it from the build tray. Once it's complete, go ahead and take the putty knife again, try and slide it underneath your part gently. In this video it pops up a little suddenly, but it's okay because we had waited for the full cooling period. So now let's take a look at the final part before any of the support material is removed. We can see the raft underneath the part, we can see the support material around the legs, as well as the support material down the midline of the front of the body. To take a look at what the raft looks like, we'll first remove this midline, and then I'll start to peel away the raft for you so you can have an understanding of how thick it is, and more challenging compared to the brim as you saw in the support material overview. So here's the final product. As you can see, there is still support material surrounding the legs. I left this on because it was a bit too challenging to remove it without using a more delicate tool. Take a look at the printing material overview video, and you can see what it looks like to use no support material for this part. And although in that version the legs and feet come out much cleaner without support material surrounding them, the part itself has a little bit more distortion due to the lack of support material utilized. This concludes part 1 in the Ultimaker 3D printer instructional series. Be sure to check out part 2, where we'll explain in more detail all the variable parameters within the Cura software. As always, never hesitate to reach out to your professors or TAs with any questions, and in the meantime, happy prototyping with the Ultimaker printer.